All right, this is 8.2. It's heat, but specifically in this video, what I'm going to do is I'm going to show you how to do Q is equal to MC delta T problems, how to do heat calculations. The formula for heat is the following: Q is equal to MC and delta T, where Q is the heat measured in joules, M is the mass of our object measured in grams, C is the specific heat of our object measured in joules per gram degree Celsius, and delta T is equal to the change in temperature of our object, which is measured in degrees Celsius. Now, one thing that oftentimes trips up students is they get confused between Q and delta T, where they'll think that delta T and Q are the same thing. They'll think temperature and heat are the same thing. But they're different, okay? Please, you need to note that Q is energy, heat, right? Heat is energy, right? So Q is saying, hey, how much energy we have. Whereas delta T, remember, the definition of temperature is that temperature gives us a measure of our energy. It tells us how much energy is present. And so don't get confused with what something is versus the measure of that thing. Delta T is a measure of energy, whereas Q is energy itself, okay? Those are different things if you think about it, right? The measurement of something is different than the thing itself. So that's our equation. Now let's use that, and what I created for you guys was this worksheet where, trying to make it a little bit relevant, we can relate it to Avatar: The Last Airbender and Uncle Iroh. Here, what we had was a system and surroundings where Uncle Iroh is boiling his tea. And so the T is the system, is what we're interested in, is what we're measuring. And the surroundings are things like his hand, him, the air. All of these things are surroundings, okay? And so what we're basically doing here is, what I wanted for us to do is to use that equation, Q is equal to MC delta T, in order to calculate the amount of energy he uses in order to heat up his tea. And so here, what we can do is we can read through this problem and try to figure out what MC and delta T are to calculate Q. And so it says Uncle Iroh is traveling to Boston, say, and on the boat, someone sells him hot tea. If you like Avatar: The Last Airbender, you know this actual scene. Unfortunately, the tea isn't really hot, and it's just room temperature. So that's something about tea. Not to be deterred, Uncle Iroh warms it up to a nice 75 degrees Celsius via his firebending. How much energy in joules does he expend in doing this? Assume the specific heat of tea is just out of water. Since tea is mostly water, this is a safe assumption. Now, the specific heat capacity of water is 4.184 joules per gram degrees Celsius. You can see that in our notes, as well as I'll give it to you over on a test. You don't have to memorize these things. And the volume of tea is 8 milliliters. And so remember, for water, right? For water, 1 milliliter is equal to 1 gram, since the density of water is 1 gram is equal to 1 milliliter. And so here we have 8 grams of water is equal to our mass of water. All right, so now we have all these things. We have the specific heat capacity of water, we have the mass of water, and here we don't have delta T. And though what you can do is you can use the equation for delta T. Remember, TFTI, delta T is equal to TF minus TI, and so you can get delta T is equal to temperature final that gets to 75 degrees Celsius. And so that's going to be final minus the initial, what it was when they sold it to him, which is 22. 75 minus 22 is equal to, 75 minus 22, that's 53 degrees Celsius. Cool. All right, so now what we can do is we can plug it into this equation. We have Q is equal to mass, which is 8 grams, C, which is 4.184 joules per gram degree Celsius, and then delta T, which is 53 degrees Celsius. Now do note, grams and divided by grams will cancel. Delta C, degrees Celsius divided by degrees Celsius will cancel, and you're left with just joules. If you put this in your calculator, you do 8 times 4.184 times 53, you will get 17740. Sorry, I think I messed it up. 0.0. joules. Now, of course, here and here and well, these two places we have only 2 sig figs. So actually, we have to round this to 2 sig figs, and so you will get this. And so you see, it's relatively simple to do these problems. All you have to do is to identify, right, m, c, and delta t, then plug it into this equation, and you'll get q. So that's the first one. Now, do note that this can be a little bit more complicated sometimes, right? You can have situations where it's like, hey, here is q, c, and delta t, and they'll ask you to solve for m, for example, right? So, you know, just be comfortable with the algebra of doing a little bit differently, but yeah, that's the basic idea here. So let's do one more for you guys. Say he overshoots 75 degrees Celsius and accidentally goes up to 85 because he won't settle for anything less than the perfect cup of tea. He allows it to cool to 75 degrees Celsius. How much energy is lost? And so still here we're trying to get Q, right? Because Q is energy. And we're trying to say as it goes from 85 to 75 degrees Celsius. And so here delta T is going to be equal to Tf minus Ti, where the final temperature is going to be 75 degrees Celsius, and then the initial was 85, and so here we see that delta T is equal to negative 10 degrees Celsius. Now that's important because that's going to result in this question where it says, what is the sign of Q? Q here is going to be negative as well. And that makes sense, right? Because here what's happening is he's allowing it to cool down. So we're not gaining heat here, right? We put energy into the water. And so, yeah, plus 1,800 joules, right? Think of it like money. When you gain money, it's positive money, right? It's like, hey, I gained $5, positive $5, right? But, you know, if you're losing money, we say, you know, you lost negative $10, right? We talk about negative money in that sense. If you ever look at your bank account and, you know, I guess you guys don't really have bank accounts, but one day you will see it says like negative $10, right? Because you spent that money. And so you're losing money technically. And so here too, we're losing heat. And so we're losing, it's negative Q from the negative temperature. And so, you know, we can plug it in and we'll see the mass is still the same, right? It's still 8 grams of water. C is 4.184. joule gram degree Celsius, still same specific heat capacity, right? But this negative 10 degrees Celsius is going to cause the Q to be negative. We put all this into our calculator. 8 times 4.184 times 10 is equal to negative 330 joules, right? And so we can see that Q is negative because we are losing heat. And so that's 2 example problems. Hopefully that helps you guys out. Let me know if you have other questions, but that's the basics of how to plug things into Q is equal to MC delta T, how to interpret these signs and things, and let me know if you have any other questions.